All right, this is lesson 1.1 in algebra. First lesson of the year. Variables and expressions. All right, we're on page 5. What is the difference between a numerical and a variable expression? In pre-algebra, we just went over this. What does the word numerical mean? What does numerical mean? Number, right? So if 2 plus 3 is a numerical expression, okay? 2 plus m is a variable expression, right? So the difference is that if it's all numbers, then it's numerical. If there's a variable at all in the whole thing, that makes it a variable expression. Now I have a quick question. What does m equal to in 2 plus m? What does m equal to? The answer is we have no idea. Right? M could be anything. In this situation, this is just an expression. M could be -6, m could be 100, m could be a billion, m could be 0.3, m could be anything. We have no idea. So then what's the difference? What all of a sudden do I have to have in order for me to find out what m is? What do I have to add to this thing to make it so I can figure out what m is? I need an equal sign, right? And all of a sudden now, this changes this right here. That part is an expression. This whole thing is an equation, right? An equation has an equal sign, right? Now all of a sudden, I've locked this in. I now have created my balance, right? My little balance guy, right? And it goes out here, and there's my little, I've created it. The equal sign says that it's equal, so now I can figure out exactly what m is. Does that make sense? Okay. What was m equal to there, by the way? 2 plus m equals 5? 3, right? M is 3. Very obvious. Okay. What is the rule about variables? Generally, variables are going to be letters, right? Almost always letters. What's the most common variable? Almost always. It's kind of the joke. It's x, right? The next common would be y. The next one would probably be z, right? But it could be anything. I mean, now why do we generally not choose t to be a variable? Because it looks like a plus sign. Why? What is so weird is that why they chose x to be the most common variable when really what does that looks like multiply? Well, so they've actually changed the way that they've changed the way that we write down things in algebra to accommodate the x as the variable, right? How do I write, what are some ways of writing multiply? If I have 2 times m, there are at least 3 different ways of me writing 2 times m in algebra, or in any way. Name one way, Kendall, that I can write down 2 times m. 2m. That is the most algebraic way you can write it, is 2m. You put a number first and then the letter. What if I said m times 2? M times 2. Guess how you write m times 2? Still 2m. Why am I allowed to do that? Why am I allowed to just move those things around? Well, what's 5 times 4? What's 4 times 5? So that is an example of what property? Do you remember what it's called? What property is that called? Commutative property. What does commute mean again? To move, right? I commuted to work today. I moved from my house to work today. I commuted, move. So the commutative property of multiplication tells us that we can move things around. As long as it's all multiplication, we can move things around and it doesn't change a thing. So m times 2 is still written 2m. Now, what's another way of writing 2 times m? Yeah, 2 with a dot m. Now, this is one of the ways that they eliminated the use of the x, right? We don't, well, what's the final way to write 2 times m? 2, right, there's another one, 2. Then, can we also do this? Is that wrong? Is that incorrect? No, that's right. It's just, what does it look like? 2xm, right? And so that's why we don't use the x symbol as the multiplication symbol anymore, because it simply, when you're writing stuff down, that looks like 2xm to me. But there's nothing wrong with that. We just don't write it that way anymore. So there's actually 4 different ways to write multiplication. How would I write, name for me ways I could write 5 times 5, or wait, 5 times 5. Why is it that, why can we go 2m, but we can't go 5, 5? That looks like 55. How can we write 5 times 5 with, and still have it be something like this? Parentheses, right? If I was to put a parentheses there, now that shows you that's 5 times 5. Okay, this is all review. We did all of this last year, but we need to make sure that you have it down. Remember? You remember all this stuff? Okay. Something else. What if I have this? What if I have x to the n? Like that. What is that thing called? What is that thing called? Exponents, right? It's an exponent. What is this guy called in this exponent? He is the, do you remember? He's the base. And this right here is the exponent. Does that make sense? Or that's the power, right? How would you say this? How would you say that properly? X to the n power. That's exactly right. So if I have 5 and a 3 up here, this is 5 to the 3rd power. Does that make sense? That's how you say it. It's important that we all are talking the same language here, because when they start giving you questions and they say, name the exponent, and what power, and if you don't know the terminology, you're not going to understand the question. Right? Okay. Let's just go ahead. Oh, right here. What is... if I'm going to give you this, if I said, 6 plus x, good Lord, how would I write that? How do I write that as a variable expression? Right? This is the simplest one. They would give you that one in like 1st grade. What about, what if I said this? What if I said the sum of x and m? How would you write that? The sum of x and m. Well, before we get to that, let's talk about this. What word is the one that you need to kind of know? Sum. Okay, so let's go over here. What does the word sum mean? When you hear the word sum, you're talking about adding things together, right? Actually, the sum is the answer to an addition problem, right? So, but sum is add, right? What is subtract? What is the word? What is the mathematical term for subtract? Difference, right? Like, what's the difference of x and 4? Or, you know what I'm saying? Like, difference, that means subtract. Difference. Okay? What is multiply? What is the word? What's the word that you're looking for? The mathematical term? Product. I could say, what is the product of 5 and 4? Your answer would be 20. Are you all hearing that? What is the product of 5 and 4? It means multiply. What means divide? What is the word that means divide? Jonathan? Quotient. Quotient. That's the word that means divide. If you don't know these by heart, you should write this down. Or you should go home and watch YouTube again and write it down then. But these you should know. You've been dealing with this since like 3rd, 4th grade. Right? You don't always see these words, but okay, so if I say the sum of x and m, that is going to be what? How am I going to write this? X plus m, right? It means add. Okay, what if I said the difference or the difference between, x and 3? What's the difference mean? There's one weird one about subtraction. You remember? There's one weird one about subtraction, and that is if I said this. This is an important one. If I said x less than 5. And this is the one that most of you are going to go less than. Oh, less than obviously means subtract, which is true. Less than means subtract. Most of you are going to go x minus 5. That is not true. And here I need you to see why. This is important so that you understand the reasoning behind this. If I have 4 less than 10, how much do I have? If I have 4 less than 10, how much do I have? I have 6. How did I get there? The math behind that. How did I get there? 10 minus 4. Do you see what I'm talking about here? You go, how much do I start with here? If I have 4 less than 10, I had 10, and I'm taking away 4, right? And so you have the less than one. That's the one that's weird, is when you see less than. Technically, so then the answer to x less than 5 is what? 5 minus x. Does that change things? What's the difference between 5 minus 3 and 3 minus 5? Can you just switch them around? They're minuses? No. What happens? They become opposites, right? 5 minus 3 is 2. 3 minus 5 is negative 2. Those are opposites. So it's very important when you're dealing with the words less than. So really, technically, though, if I have m more than 6, right? If I have m more than 6, what is the technical way of writing this? It's 6 plus m, right? I started with 6 and I have m more than that, 6 plus m. The reason why it doesn't usually get you in trouble with more than is because what is 5 plus 4? 9. What's 4 plus 5? 9. See, there is a commutative property of addition, and so it's not as important with addition because you can switch them around and it's no problem. But with subtraction, there's a problem. You have to do it in the right order. Make sense? Okay. Let's do a few of these samples because really this is pretty straightforward stuff. Let's turn to page 7. Turn to page 7. This time they're going to have you write a verbal expression. What's verbal? The word verbal means or words, right? Verbal means words, saying them. And so it says write a verbal expression for this. So if I have 2m and they want you to write a verbal expression, in other words, now you're going to undo this and you're going to put this out into words, what would you say? What could you say? There are several things you could say here. What would be the simplest one, the one that a kindergartner would say here? You'd say 2 times m, right? Okay. As an algebra student, what should you say? The product of 2 and m. That is way more algebraic to say the product of 2 and m, right? Make sense? Okay. What about number 3 on the top of page 7? This is a tough one. This one, you start to go, okay, whoa. You just, how would you say this? I mean, we can just read this. I mean, like, and I would say for this one, it's not as difficult as it may look like it might be. Read it to me, Sladen.
The difference of 8 to the second power and 18b.
That's right. That's actually right. That's good. He said the difference of, what's that mean? The difference of, isn't that dealing with that subtraction guy right there? The difference of 8 to the second power and 18 times b. Or you could, if you want to get technical, let's do this technically. It would be the difference of a to the second power and the product of 18 and b. No, I'm not going to make you do that. It's not that important. None of this is that important. I'm just saying that, you know, if you were to, you could also say a to the second power minus 18 times b. You see what I'm talking about? Is that wrong at all? A to the second power minus 18 times b would work just fine. Question?
So, like, would you, like, technically, would you say the product of A and A? Or would you
Technically, you could. Yes, that's why there's an infinite number of ways to do this. I'm not worried about it. You just need to, you know, I would say on your homework, do it the simplest way possible. Right? Do it the simplest way. Let's look at number 15. What would you do? I mean, just look at that. I'm not trying to trick you in any way here. I don't want the book. I don't feel like anything's trying to trick you. Look at number 15. How would you say? Give me a verbal expression for that. You could say 3 times x squared. That would be okay with me. But what would be a little bit more of a better way of saying that, Lauren? Right, the product of 3 and x to the second power would be excellent, right? So, whatever. I'm not too worried about it. You guys should do fine here. What about number 19? Do that correctly. Think it through. It's x more than 7. How would you write that down as a variable expression? X more than 7. What do you got? Joy, what would you put there? That is almost the right way, right? Remember, it's 7 more than. When you see less than or more than, it's going to be flipped, right? It's going to be flipped. So it'd be 7 plus x. It wouldn't cost you. Why wouldn't it cost you? Because it's addition. And what's the rule what's the rule? What's it called? The commutative property of addition. So then you wouldn't get in trouble. But okay, what about 20? They don't give you the variable. What would you do if they don't give you a variable? You just choose one, right? It doesn't matter. Pick whatever one you want. So what would it be? Does it say less than? It just says less. So if I have, listen, if I have $10 less 2, how much money do I have? 8, right? If I have 10, so if you just see the word less, that means minus. That just means straight up minus. So if I have a number, x, less 35, it's x minus 35. Does that make sense? It's less than that changes things. I know it sounds nitpicky, but it does change things. Try to remember that. Just the word less means subtract. Okay? I don't know. Looks pretty simple to me. Let me see what I got for you for homework. Hold on. Right, I know. All right, here we go. Here's the deal. Here's your homework. You are on page 7 through 9. Yeah. 1 through 30 even. And 53 through 61 even. Let me make sure that that's what I want. Yeah. No problem. Okay, there it is. It's due tomorrow.